Wireless technology refers to communication systems and devices that transmit data over the airwaves without the need for physical wired connections. It has become an integral part of modern life, enabling various applications such as mobile communication, internet access, remote sensing, and automation. Here's a general overview of how wireless technology works. Transmission of data. In wireless communication, data is transmitted using electromagnetic waves, such as radio waves, microwaves, or infrared waves. These waves travel through the air and can pass through obstacles, allowing communication between devices without the need for physical connections. Modulation. Before data is transmitted wirelessly, it is modulated onto a carrier wave. Modulation involves varying certain properties of the carrier wave, such as its amplitude, frequency, or phase, to encode the data being transmitted. Different modulation techniques are used depending on the specific wireless technology and the requirements of the application. Transmitter. The transmitter is the device that generates and sends out the modulated carrier wave carrying the data to be transmitted. It converts the digital data into analog signals suitable for transmission and amplifies them to the desired power level. Receiver. The receiver is the device that captures and demodulates the modulated carrier wave to extract the original data. It converts the analog signals received from the airwaves back into digital data suitable for processing and interpretation by the receiving device. Antennas. Antennas are used to transmit and receive electromagnetic waves in wireless communication systems. They convert electrical signals into electromagnetic waves for transmission and vice versa for reception. Different types of antennas are used depending on the frequency, directionality, and range requirements of the wireless communication system. Propagation. Once transmitted, electromagnetic waves propagate through the air, following the principles of wave propagation. Factors such as frequency, distance, obstacles, and environmental conditions can affect the propagation of wireless signals and may cause attenuation, reflection, diffraction, or interference. Protocols and standards. Wireless communication systems rely on various protocols and standards to ensure interoperability, compatibility, and efficient use of the radio spectrum. These standards define rules and procedures for data transmission, error detection and correction, channel access, security, and other aspects of wireless communication. Frequency bands. Wireless communication operates within specific frequency bands allocated by regulatory authorities. Different frequency bands have different characteristics, such as range, penetration through obstacles, and susceptibility to interference. Wireless technologies use different frequency bands depending on their requirements and regulatory restrictions. Security. Wireless communication systems incorporate various security measures to protect data privacy and prevent unauthorized access or interception. Encryption, authentication, access control, and other security mechanisms are used to ensure the confidentiality, integrity, and availability of transmitted data. Overall, wireless technology enables flexible, convenient, and efficient communication between devices and systems over long distances without the constraints of physical wires. It continues to evolve and advance, driving innovation and enabling new applications in various fields.